This video is going to discuss linear momentum. Students will be able to recite the equations and components of momentum and impulse. The definition of momentum is the product of an object's mass and its velocity. Since velocity is a vector quantity, meaning it has magnitude and direction, momentum is also a vector quantity, meaning it has magnitude and direction. Momentum is not a scalar. The equation for linear momentum is P equals mv. The P stands for momentum, m is mass, v is velocity. That's a lowercase p in case it's not really obvious from the text. Capital P means something else. The units for momentum are equal to mass times velocity, so you have the mass units, which are kilograms, times the velocities units, which are meters per second. And there's no special unit for this, so you just smash them together and you end up with kilograms times meters per second. So I might just say kgm over s, or kilogram units meters per second. This means that the more mass an object has and the faster it's moving, the more momentum it has. We've already discussed Newton's second law of motion as the net force equals mass times acceleration, but Isaac Newton originally defined the second law in terms of momentum. He said that the change in momentum equals force times the change in time. That's this form right here. So if we start with that equation and do some math, rearrange it so we have force equals change in momentum divided by change in time. And we say that the change in momentum is the final momentum minus the initial momentum divided by time. And we factor out that mass, so we have m times the change in velocities divided by time. Then v minus v is really just the change in velocity over time, which is the same thing as acceleration. So this over here, delta p over delta t, is really the same thing as ma. Change of momentum, or delta p, is commonly called impulse, and is defined as force times the change in time. Which of the following units could be used to measure the momentum of an object? Number 1 says kilogram meters per second, 2 says newtons times seconds, 3 says newtons times meters. If you're looking at 2 and 3 and thinking, they sound kind of crazy, and you're thinking the answer has to be A, then you are incorrect. Because since 1 newton is the same thing as a kilogram meter per second squared, so if you times that by seconds again, it cancels out the squared second, and you're left with the units for the first one. So 1 and 2 are both acceptable units for momentum.